boys and girls, it's Miss Pacelle. Welcome to your video lesson today. We are continuing what we worked on yesterday. Our focus today is strictly going to be line graphs. We're going to continue interpreting the data that are on different graphs, and we're going to continue a little introduction to analyzing the trends. I introduced that very subtly yesterday when we looked at the rises and falls of the lines between a couple of the data points. Tomorrow we'll formally get to that lesson, but we're just going to get a little introduction today. Our essential question that you want to make sure you can answer by the end of the instructional video is, how can you use a line graph to interpret data? And don't forget, interpreting data just simply means you're able to look at a graph, in this case a line graph. You're able to read the title, you're able to look at the axis labels, you are interpreting what's going on. That means you are having an understanding of what this particular line graph is showing. As a matter of fact, you could probably come up with some good questions about the data on the graph. All right, so let's just review some things about line graphs. Line graphs show data that changes over time. All right, a good example of that might be your, batting average. If you play softball or baseball, maybe your coach is looking at your last 5 games and they have been keeping track of your batting average, and they're looking to see what's going on. What's the trend? Are you getting better? Are you getting worse? Maybe your mechanics are suffering and you need some lessons in the cage. But what does the data say? All right, the data is shown with points on the graph that are connected by lines. When I look at this one, I like the fact that the points are actually little diamonds. Kind of cool there. Trends are seen by analyzing the rises and the falls of the lines between the data points. We did that a little bit yesterday, but basically what we're doing, we are looking at the slope of the lines and figuring out what the heck is going on here. So I notice, and first of all, I think I cut off the label of the y-axis. I think this was supposed to be cartons of milk sold. So I see that from Monday to Tuesday, there is a rise, all right, in the number of sales of chocolate milk. I see the same thing from Tuesday to Wednesday. It's an even sharper rise. Then I notice a pretty steep drop in sales between Wednesday and Thursday. And last but not least, there was a rise in sales from Thursday to Friday. All right. So that is what we're looking at when we talk about trends. What do we see? All right. So we are actually going to be doing our own line graph the last lesson in this unit, where we construct a line graph. So this lesson will just give you a preview of what you'll be doing. But when we draw line graphs, we plot the points on an axis. So this table shows the speed of a go-kart at various times as it drove around the track. So here is the data collection in a table. So the time in seconds and the speed. And obviously, it's at 0 seconds when it just starts out, it's not moving. So the speed would be 0. And then as the seconds increase, you see the speed increasing until about 40 seconds. It looks like at 40 seconds, they're slowing back down. And I would make an educated guess that in about 60 minutes, this particular go-kart is going to be stopped at 0 miles per hour again. But anyways, you have to gather your data and you have to gather it accurately and represent it in a table before you can even think about graphing it. So first you draw your axes. You choose a number scale which fits on the paper you have, but it also has to include 0 up to your greatest data point. So we have to show from 0 at least to 45. This one goes from 0 to 50, so that works well. All right, we're going to plot each point along then up. So what they mean is we go over then up. We'll talk about that in class. And then we join the points as shown. One thing they didn't talk about was the intervals, or the what we call the intervals between the scale. So in the scale, we go from 0 to 50, and this particular graph is labeled with intervals of 5. And what I know is that 5 is on every other one of these horizontal lines. So what that tells me is this one line in the middle is where 2.5 would be, or 2 5/10, right? This would be in the middle. This would be 7.5, or 7 5/10. So really, this shows me that the scale increases by 2.5 each time, or 2 5/10 if you're talking decimals. All right, so we'll get to that when we have the assignment the last day. All right, here is a line graph that shows push-ups from Monday through Saturday. All right, and the number of push-ups are on the y-axis. This is well constructed. So let's stop and answer some questions and see how we recall what we learned yesterday. So between what days do we see the greatest change in the amount of push-ups that the student does? I would say when I look at this graph, the answer is going to be between Friday and Saturday. Now, what this person has done, and I love it because I do this too, where the points are, I like to put the number that corresponds with it. All right, so each of these points correspond with the number of push-ups that's labeled there. So I see that there was the greatest change in the amount of push-ups would be 15 from 25. There would be a 10 push-up change here. 15 to 25, there would be a 10 change here. From 25 down to 5, there would be a 20 push-up change. From 5 to 10, a 5 push-up change. And from 10 to 0, a 10 push-up change. And from 0 to 20, a 20 push-up change. So actually, I changed my answer. The answer is between Tuesday and Wednesday, and between Friday and Saturday. Both those days had a difference of 20 push-ups. All right. Oops, I missed the second question. What day does the student take a break in exercise? So think about what that means. What day does the student take a break in exercise? The correct answer would be on Friday, where 0 push-ups were completed. All right. Take a look at, analyze this graph a minute. Make sure you're reading the title and the axes labels. What is being measured? What is being measured is the temperatures in New York City in degrees Fahrenheit over a 5-day period. 6-day period, sorry. What day do we see the hottest temperature? The hottest temperature would be on day 6, 67 degrees. One quick way to see that is that it is the temperature point that is at the greatest point on our y-axis. And what day do we see the lowest temperature? The answer would be on day 1 at 43 degrees Fahrenheit. That one is at the lowest point on the y-axis. All right, let's take a look at this average monthly rainfall line graph. This one's a little different. This is a double line graph. It actually compares data from 2 cities. City 1 is plotted in green. City 2 is plotted in blue. What is being measured? We are looking at a measurement of the average monthly rainfall for 2 cities between the months of January and December. So this data would have been tracked over a year. What is the amount of inches in January for both cities? When we look at January, we see that the city 1 in green has 5 inches. The city in blue, city 2, has just a little bit over 2 inches. So together, they would have just a little over 7 inches of combined rainfall. What is the difference between the amount of inches of rain between both cities in July? The answer would be there is a 1-inch difference of rainfall between both cities in July. City 1 had 1 inch, City 2 had 0 inches. So I'm looking along the July, I subtract, I get a 1-inch difference. All right, this graph does not have a title, but I think if I were to title it, looking at these years from 2010 to 2014, and then we're looking at mobile phone sales in millions, I would think that we would title this cell phone sales or mobile phone sales. That's the same thing. Now, one thing I need to point out, boys and girls, it talks about that the sales are in millions. So this does not mean that one cell phone or mobile phone was sold in 2010. It means 1 million. This data point right here would mean that in 2011, 3 mobile phones weren't sold. It's 3 million. Same thing with this data point right here for 2014. This is not representing 5 mobile phones being sold, it's 5 million. So always be sure you read very carefully your X and Y axes. All right, so what year did we see the least amount of phone sales? Yes, the correct answer would be 2010. Only 1 million were sold. What year did we see the largest amount of phone sales? The correct answer would be 2014. There were 5 million sold that year. What was the difference in the amount of phone sales between 2013 and 2014? 1 million. If you look in 2014, we've already noticed there's 5 million in sales. 2013, this is 4 million. 4 million subtracted from 5 million gives us a difference of 1 million. All right, seal count at Seal Point. This line graph has the title at the bottom. I will tell you that it took me a few minutes to find it when I first saw this one. It should be at the top. That would make it a lot easier. Now, again, this graph, as pretty as it is, has some great information, but it is not well constructed. All right, I do not see an x-axis title or a y-axis title. So I can only assume that these numbers represent the count of seals during these years as the numbers 10 through 50. I am thinking it could be thousands, but it doesn't tell me that. So let's just use it for practice today as we're looking at 0 up to 50 seals. So how many seals were counted in 2010? How many seals were counted in 2010? Yes, that answer would be 35. Now, I know that because I follow my 2010 up and over, and this data point lies in the middle of 30 and 40. Right in the middle of 30 and 40, our halfway mark would be 35. That's where I get that answer. What is the difference between the number of seals in 2013 and the number of seals counted in 2008? All right, the answer is 20 seals. Let's take a look at where I got that information. In 2013, we see that the data point is right here between 40 and 50, so that would represent 45 seals. In 2008, the data is right between 20 and 30, so this would represent 25. 25 from 45 would give me the difference of 20. All right, this is the average hours of sun per day. All right. And I would like to talk about the trend in the average hours of sun per day as represented by the graph. So I'm going to talk a little bit through this one. So we look at, it appears to me, these are the months of the year, January through December, and this is the average hours of sun per day. So what I notice is In the winter months, which would be December, January, February, look how few hours of sun there are per each day. Few hours. And then the summer months, which would be June, July, August, look how many hours of sun there are. So what I see is that in the winter, there is very few hours of sun per day. As the months move on, the number of hours of sun per day increase. They peak in the summer, and then they begin to decline in the fall. And when we're back to winter, we are at our least number of hours of sun per day. So that would be the overall trend. All right, what month did we see the least amount of sun per day? Take a minute and look at the graph, and let's see what you say for that answer. And that is correct. It is January. Now, you're probably saying, where are the data points? And again, not all graphs are great as far as construction. I would have data points at the meeting of each of the lines. All right, but we can still read it. How many hours did we see of sun in November? And that would be 2 hours. November would be represented right here. Follow it over, 2 hours of sun. All right, so we're at the end of the lesson. You should be able to answer today's essential question: how can you use a line graph to interpret data? So you're using the line graph, just like we talked about yesterday. You're going in, you're reading your title of your graph, you're really looking at the you're looking at the X and Y axis, and you're looking at the titles there, you're looking at your categories, you're looking at the scale, you're even looking at the increment from one number to another on the scale, and then you're looking to see what happens from line to line as you move from one data point to the other. What trends are going on? Are you seeing increases in data points, like increases from one to the next? Are there decreases? Are they remaining constant? Okay, so those are some things that you are going to be able to interpret data from looking at line graphs. All right. If you feel like you need to watch the video again, that's the beauty of videos. You can always go back and watch it again. Have a great day.